How can this lettering be placed on this cross? It's quite simple. Take a photo of the workpiece, create the design and send it to the CNC machine. I will show you step by step how to do this using completely free tools. Let's start by taking a photo of the workpiece. Keep the following points in mind to get a good photo. Firstly, make sure that the camera or smartphone is positioned at the same level as the workpiece. Secondly, it is best to keep a large distance between the camera and the object in focus. This reduces any perspective distortion and ensures an accurate measurement. Use the camera zoom to enlarge the object in the photo. I also put the folding ruler in the photo so that I have an exact length reference. But this is not a must. By the way, if you are working with small pieces, you can just use a scanner to get a very precise photo of your object. To set the design onto the photo, I use the free software Inkscape. It's perfect for designing pixel and vector graphics, and it supports all units of measurement, which makes it easier to handle dimensions. However, you can also use any other graphics program, as we don't need any special features. We need to make the workpiece the right size before we start designing. To find the current length, I draw a rectangle along the folding ruler. I get a length of 179 mm, but it should be 2000 mm, the length of my folding ruler. So I need to scale the photo and need to calculate the scaling factor by dividing these numbers. Inkscape needs a percentage value for scaling, so I multiply it by 100. I make sure that everything is selected, then I change the unit in the scaling toolbar to percentage. I also make sure the aspect ratio is locked and finally set the scaling factor. Okay, when everything went right, the rectangle should now be the same length as my folding ruler. A quick check confirms this. Now, when everything is the right size, the design can be made. The color will play an important role later on. Black should be used for the general design. To let the CNC know where to start, I will define a 0 point here. I will look for a clear feature in the wood structure, such as this branch, and draw a red reference line on it. Later in the CAM program, I will define the 0 point on this line. To create the toolpaths, a graphic of the clear design without the workpiece in the background is needed. So I cover the design with a white rectangle and move it behind my design and in front of the workpiece photo. The design is now ready to be exported as a pixel graphic. But why a pixel graphic? We will find out the huge advantage later, so please wait and see. To export, I select a white rectangle. Then in the Export tab I choose Selection mode. This limits the exported area to the size of the selection. One very important point is the graphic resolution. This value is very important to keep the correct size for creating the toolpaths. For those working in millimeters, it is necessary to convert between inches and millimeters. 25.4 dpi, dots per inch, corresponds to 1 pixel per millimeter. A good value is 5 times this amount. So, multiplying 25.4 by 5 gives 127 dpi. This means 5 pixels per millimeter. Okay, let's name the file and export it. We are now ready to create the toolpaths. Therefore, we will switch to send2cnc, the CAM software. I'm using the basic edition, but the free edition can also be used. You will find the download link in the description. With send2cnc, it's possible to calculate 3D toolpaths directly on pixel graphics without vectorizing the design. Pixel graphics can be greatly automated. I will demonstrate this using this existing project. How such an NC project is created from scratch, I will explain in another video. For now, just make sure the resolution in the project settings matches the exported graphic. For me, that's 5 pixels per millimeter. All I have to do is drag my graphic into the project and select Drag and Mill from the context menu. Send2cnc now creates a new project in the graphics directory. Then it searches the project for exchangeable geometry and replaces it with our graphic. With just one simple mouse drag, we transformed a design into an executable CNC program. This is a huge advantage of using pixel graphics. Unlike with vectors, the software can already identify what is inside and outside due to the coloring. And this makes automation possible. If you like this alternative approach, please subscribe. I will show you all the tricks to create safe, optimized and automated CNC toolpaths in no time. Okay, our CNC program could already be started. But wait, there is one thing to do before. I have an individual 0 point and therefore have to set this to my marker. This can be fixed very easily. Just right click on NC0 and pick position. Now the 0 point can be placed anywhere. The marking should not be milled. For this reason, it is important that the marker is shown in red in the graphic. To hide it, a color channel filter can be used. Rather than using red, green and blue, only the red channel is used, which causes the mark to disappear. As you can see, without the green and blue channels, the red mark is hidden. To change the color channel, I open the model settings and switch from RGB, red, green, blue, to red only. This small feature opens up many opportunities, but that's another topic. Okay, after the change, the job needs to be calculated again. Users of the Basic Edition should definitively activate the V-bit optimization in the job settings. This reduces the milling time to a fraction and increases the quality of the engraving. That's it. The post-processor window enables us to generate both an executable NC program and a machine setup sheet. This document contains important information for setting up the machine safely. Today we learned how to take a photo of a workpiece and resize it, how to automatically create CNC toolpaths based on a reference project. We also learned how to use different colors, for example as markers. So let's put the workpiece into the CNC and start it up.